Hello, Honors Pre-Calc. This is one of my favorite lessons and units to teach, and I'm hoping it's just as good as on videos, but we are gonna make do here. So this is the first kind of trig extended. So what happens in trigonometry outside of right triangle trig? So you'll see this kind of circular thing here. We're going to get into what's called the unit circle. Before that, we're just going to look at what does this mean trigonometry outside of this right triangle. So I have this Unit 6, Lesson 4 notes I will send out to you. I'm going to go through this here on OneNote this time. So I'll just kind of go through these notes here, and then I'll put up the video. So all right, we have basically, we're going to get into angles. So far we've been using triangles, and all angles in a triangle are 90 degrees or less, or greater if it's an obtuse triangle, but we're not getting into those with trig. So this kind of trig is going to involve angles greater than 360 degrees or less than 0 degrees. And so let's get into kind of talking about what that means here. So when we talk about this kind of trig, we have this circular unit. So this kind of works like a clock or like a game board that you spin. And so when we think about a clock, right, the 12 is up here, and this is where everything is based off of. It's that same idea here, except now everything's based off the initial side is the positive x-axis. So basically, the vertex here is always at the origin on this graph. And then this angle is the positive x-axis. So the graph, this angle, like kind of shifts. Basically, everything in a clock is based off up here. Everything in this trig starts from here to the right. Okay? So this is what's called the initial side, where it starts. Okay, and then you're going to have another side, and that's kind of like the hands on the clock that spin, or a game piece that spins around. And so that's called the terminal side, and it's going to rotate around this circle. Okay, and so I could have basically an angle right here. Maybe I'll draw this in and then erase. Okay, so here's an angle. This angle's measured from the initial side up to the terminal side. Whoops, I forgot to turn off Teams. Maybe Sophia's laughing at my extra credit joke. Okay. I can do that from here, can't I? So here's one option. This could also I'm becoming such a pro at this now. Like, now I get you guys working in my class. Could be over here, and now here's the angle, right? So this terminal side kind of rotates around. It could be any of these things. Okay. And so all of these angles that I just drew are positive. Okay. Angles measured in a counterclockwise direction are positive. So from the initial side, counterclockwise means against the way the clock goes. So we have to kind of consider that. When we think about a clock, the clock starts up here and goes around like this. So this is called clockwise, which means counterclockwise is going to be the other way. Okay, so basically when we're at the initial side and we go up, we're positive. Okay. And then if I'm at the initial side and then I go down, maybe I'll use green even though these are blue, and I go clockwise, that's going to be negative. So I can have this same angle that's over here where before we went around this way and it was positive. Now I'm going to go down this way and it's negative. Okay. So I can do this same thing here, and I can go this way, and then that's also negative. I could go up here, and that's also negative. I could go up here, and that's also negative. Okay, so measuring. If I'm at the initial side, I go up, it's positive. If I go down, it's negative. All right. So let's look at actually trying to measure some of these. So we remember that we have quadrants here. Okay, so I'm going to talk a lot with quadrants. So here's my first quadrant, second quadrant, third quadrant, fourth quadrant. All right. So when I start here at the initial side, basically everything that we've dealt with so far in right triangles has all been in the first quadrant. Okay. So now we're kind of moving around here. So, oh no, not the initial side. All right. When I think about angle measures, where I start at the initial side is 0 degrees. Okay. I'm going to go just positive first, and then I'll try to talk through negatives. It's the same idea, but backwards. Okay. So the next one, when I go positive, I'm going counterclockwise. Up here, you should recognize, if this was my terminal side, this is going to be a 90-degree angle. We know that already. Okay. If I go all the way to here, right, this is a straight line, which is 180 degrees. Okay. If I go down to the next one, that's going to be 180 plus another 90. That's 270 degrees. And then one more gets me back to 0, but it's not going to be 0 anymore if I've gone through the whole circle. It's now going to be 360. Okay. And then I technically can keep going, right? So I can keep going. I can add on another 90. I can add on another 180, and I'm going to get larger than 360, right? So basically, I can spin here around the circle multiple times. Okay. And so that's kind of what we're going to get into. All right. So if we think about that same thing, but with negatives, same thing, I always start here at the initial side. Okay, that's going to be 0. But now I'm going clockwise. Okay, so I have 0. When I get down here, I'm at negative 90. Okay, because this is 90 degrees, but now I'm just in a negative direction. When I get here, I'm at negative 180. I get up here, I'm at negative 270. And then negative 360. And again, I could keep going around the circle. Okay, so that's just going to shift based on if you're going upwards and it's positive or downwards and it's negative. So just really quickly, these angles on the axes are called quadrantal angles. Okay. So if I say that, that's what I mean. The quadrantals are these 90 degrees or multiples of 90. All right, I'm just gonna actually write the positives here too so we can remember. Right, so like negative 90 is negative 90, but it's actually the same as positive 270. So those angles are in the same spot. All right, so when we measure angles, all right, we're gonna measure here what's in this red thing, the red circular process, I guess. I don't know, process, where I got that from, but so we always start at the initial side, all right? So I'm gonna start here. That's where this angle's starting from. Now this one's going up, so I know it's gonna be positive, right? My red line here from that initial piece is going up. All right, so I can count this however I want. I see that this is going around the circle more than once, okay? So up to here is 90, and like I could just count by 90s, but I know it's already around more than once. I know this to here is gonna get me to 360. And then it's actually gonna go around a whole nother time to another 360. And from there, it's not going around a whole nother time, it's just going around this much, which they tell us here is 125. I'm going to add these all together, and that should get me my answer. Okay, so I have 360 plus 360 plus 125, and there we go. So this angle measure is 800. Okay. 45 degrees. Okay. So you're welcome to count by 90s, right? 90 plus 90 plus 90 plus 90, blah, blah, blah. You'll get the same answer, but I know this is going around full times, 360 plus this 125. All right. The second one is smaller. We can see it's not going to go around as many times. So I always start at the initial side here. This time it's going down, so I know this one's going to be negative. All right, so let's count how many full times it goes around again. So this gets me here to negative 360. Okay, and actually though, when I add this up, I'm going to add it up in positives, and then I'm just going to add this negative sign at the end. Right, the whole angle's negative, so we're adding negatives on negatives on negatives. But sometimes the negatives and the positives get us confused, so we'll just add these all in positive measures and add the sign at the end. All right. So this gets me to 360. Now, it doesn't go around a whole nother time. It gets me here, okay? So let's see. What's different about this one is that this 70 is not part of the angle. This 70 is an extra piece out here. What that does help me find out is that I know that this is always going to be a right angle, 90 degrees. And so if this is 70, that means this piece here is 20, because 20 plus 70 is 90. And so now what I know, okay, we already got to the 360. I know this right here is 180, because that's half the circle, plus this 20. So I'm going to take this full 360 plus 180 plus 20. That should get me my answer. So this ends up being 560 here, and then we have to remember we said it was negative. Okay, measuring angles. So these are the same idea, but now we're just drawing the angles in ourselves. So now we just have to label the quadrantals and see where we're at. All right, so this is 600, so I know it's bigger than 360. I always start at the terminal side. This is 0. So I know it's going to get all the way to 360, right? We don't even really need to put the 90s here yet. So let's figure out what's the next time it gets around. 360 plus 360 is 720. I don't know if any of you skateboard or watch snowboarding or skiing or something like that, but this is exactly what they're talking about, how many times they spin around. So I know my angle is going to go at least to 360, but it's not going to get around to 720 because it's only 600. So after 360, I kind of got to place, okay, now what are the quadrantals after 360? So we know 360 plus 90 is 450. 450 plus 90 is 540. 540 plus 90 is 630. And then 630 plus 90 is 720. So these are our new quadrantals here. So now I can kind of say, okay, 600, well, I know that's in between 540 and 630. So now I just have to make sure it's going around the times we were just talking about. And I can put it anywhere in this third quadrant, okay? I'm not going to be like, oh, it's too close to this one or the other one. So I start in 0. I know this goes around at least one whole time. Now basically we're just drawing in this same idea, this red circular thing from the last problem. Okay, so this got us to 360, and now I got to go past 450, past 540, not to 630, so we're just somewhere in here. Okay, I'll draw in my terminal side, and then that's our angle. Okay, so basically we're just setting this up, actually drawing it in. All right, negative 665 is the next one. We'll notice now this is negative. So our terminal side still starts in the same place, but now we're going around negatives. So I'm going down. All right, so that gets us to negative 360. Now, good thing is this angle's close to the other one, just in negative, so we already found these quadrantals. So this is going to be negative 450, negative 540, negative 630, negative 720. And it doesn't go past that, so we can stop there. All right, so we're starting here. We know it's negative. Okay, we know, same reason as before, it goes at least to negative 360. Now we're negative 665. So that's going to be all right. We got to go past negative 450. We got to go past negative 540, past negative 630, but not quite all the way to negative 720. So we're somewhere here in this first quadrant. Okay, again, I don't care where you stop in there. And that's our negative 665. All right. So that's the basics of measuring positives, negatives, angles, all that. Okay. So there's two others, coterminal angles and then reference angles. So coterminal angles, just gonna add in plus or minus. So coterminal angles are standard position angles that have the same terminal side. Okay. So what does that mean? We can already see some coterminal angles in this picture. 0, 360, negative 360 are all coterminal because they all land at the same place on the circle. Same thing, 90 and 270 are both here at the same place. They have the same terminal side, negative 180 and 180, negative 90 and 270. And I could get an infinite amount of other angles at this same place by just continuing to go around. Okay? And so I get the definition for coterminal by it's adding or subtracting multiples of 360. Because if I'm here and I go around a whole nother time, well, that's adding on 360. Or if I'm here and I go around this way, it's the same thing. I'm subtracting through 360. And I could keep doing that over and over and over. Okay? And so this is a definition here for coterminal. To find angles coterminal to a given angle, add or subtract multiples of 360 to and from the given angle. All right, so I don't normally use this K that much, but you're welcome to. All right, so let's say we use a 145 degree angle. So here's 0, here's our initial side. This is 90, this is 180, so 145 is going to be somewhere in here. All right, so basically, if I go around from there one full time, a whole nother time from 145 around the circle, 360 degrees, right? I'm going to take this angle, 145, and add 360, right? Whatever that is. 505. Let me just make sure. I can't record a video and also do math in my head. All right. This also gets us 505. Okay, what that means is that 145 and 505 are coterminal angles. Meaning 145 is just this. And then 505 is this plus a whole nother time around the circle, but they land on the same place. All right, I can do the same thing if I go negative. So if I'm at 145, and instead of going this way, now I go around this way, I subtract 360. That gets me to negative 215. Okay, and that's because that's going to mean this, right? If we go and have a negative angle, this is 0, negative 180, and a little bit more than that's negative 215. So all three of these are coterminal angles. They land in the same spot, they're just differing by multiples of 360. And so you can do that over anywhere in the circle. All right, so state if the given angles are coterminal. So basically what I need to do these type, is just to make sure that the angles differ by multiples of 360. So you can choose either one of these to start. If I have 265, I basically need to try to turn it into negative 455 by subtracting or adding 360s. So I know if I'm at 265, to make it a negative 455, I'm going to have to subtract because I have to turn it negative. So I'm going to subtract 360. That gets me to negative 95. That's not far enough yet, so I got to subtract another 360. All right, look at that. We got there, right? It's fine if I go around more than once. I can go around more than once, so I can subtract more than one 360s or add. So I subtract another 360, and it gets me to negative 455. We started here, we ended up here. That's good, so yes, they are coterminal. So if you do one of these where they don't end up being the same, then that's when you would say no, they are not coterminal. Okay. All right, number 6 here, find a positive and negative coterminal for each given angle. So there's infinite amount of answers for these. The homework's going to only give you one option, but you could add 400 360s if you really wanted to, but you don't have to. So I have 440. I want to find a positive and a negative coterminal. So I could just take 440 and add 360. That's going to get me a positive number, right? It's also going to be coterminal. So this is 800. So that's a positive. So now I just need a negative. So I know if I'm going to make 440 negative, I need to subtract 360. Now hopefully some of you are seeing this isn't going to get me negative because 440 is bigger than 360. This gives me 80. And what that means is both of these would work for a positive coterminal angle. Okay, you don't have to do this one if you don't want to. Either of them are options. Okay, so this gets me to 80. It's not negative yet, so I need to subtract 360 again. That gets me to negative 280. So here can be my positive, here can be my negative, or you could use 80 and negative 280. You could subtract another 360 if you want. That gives you negative 640. That's also a negative coterminal angle, so that's what I mean by there's infinite amounts. You can do any of them here. All right, that's coterminals. Last is reference angles. Okay, a reference angle is acute, positive. So even if your angle measures negative, reference angles are always positive. And it's measured from the terminal side of the angle to the x-axis. Okay, so we always start, right, with our initial side. Okay. So basically, we only use for this the x-axis. Okay, so I'm only going to be subtracting things from the x-axis. You're never using the quadrantal measures on the y-axis, ever, ever, ever. Okay, it also is acute. What that means is wherever your terminal side lands, it can't go outside of the quadrantal that's closest to it on the x-axis. Because if I have one in here and I measure it with something up here, well then that angle is going to be obtuse. Okay, so it has to be acute, which means less than 90. All right, so if I'm in these different quadrants, all right, so these are all examples. Okay, so if I start at 70 degrees, right, if these are all positive, so I know 90, 180, 270, this is 0 and 360. All right, so if I start at 70 degrees, my reference angle is just going to be the theta because it has to be acute, right? And remember, I'm only using the x-axis. So I can't go to this part of the x-axis because that measures more than 90. It's obtuse. And so my reference angle is just going to be right in here, okay, which is theta. When we say reference angle, this is actually a new Greek letter. Reference angle, we represent with alpha. Okay, so this is actually theta, and it's also alpha, which is my reference angle. All right, so down here, the reference angle for 70 is 70. All right, if I have 130, 130 is going to be in the second quadrant, right? More than 90, less than 180. Okay, so this is now my theta, is 130. All right, well, 130 is obtuse, so I know it can't be the reference angle because reference angles have to be acute. It's measured from the terminal side to the x-axis, so I know I can't go back to the 0 because that's obtuse. And so my alpha is actually in here. This is my reference angle. It's between 130 and the x-axis. And so you can probably already see that, right? But if you're in the second quadrant, you're going to do 180 minus your theta. So I already can see, right, the difference between these is 50 degrees, 180 to 130. But basically I can subtract that. So this is going to give me 180 minus 130, which is 50. You know, you don't have to show me that work for these if you can see that in your head. But when we get into bigger angles or negative angles, you probably want to work on that subtraction. All right, so my reference angle for 130 is 50. Okay. So next one is in the third quadrant. My third quadrant here is 240. Right, it's in between 180 and 240. Okay, so now I know I'm starting here. I'm going around to the third quadrant. That's my theta. All right, that gets me to 240. All right, so it's the same idea here. The alpha's in between the terminal side and the x-axis. I can't go to this x-axis because that's obtuse. Remember, I can't use this because this is the y-axis, not the x-axis. And so my alpha is in here, which is in between 240 and 180. And so now I really just have to subtract the same way, but I have to put the 240 first to make sure that the angle measure is still positive. Right, so this is now your theta measure minus 180, so that's going to be 240 minus 180, which is 60. Okay, so this alpha here, this reference angle is 60. All right, last one, 330. I guess I'll just use blue. All right, 330 we know is going to be in our fourth quadrant between 270 and 360. Right, so now my alpha or my theta is 330. Okay. My alpha is again between the terminal side and the x-axis. I can't go back to 180 because that's obtuse. So my alpha is in here between the terminal side and the x-axis. And so I'm not going to use the 0 here. The difference between 0 and 330 is obtuse angle, and it needs to be acute. So I'm going to use the 360. You can probably already see it. The difference between these is 30, so that's my reference angle. But basically here now we use 360 minus theta, right? So this is going to end up being 360 minus 330, which is 30. Again, you can probably do that in your head, but all right, that's reference angles. So just going to look at two really quickly that are greater than 360 or less than 0. So to find the reference angle for an angle larger than 360 or less than 0, use the same rules, but use the coterminal angle measures of the x-axis. So all that means is we just have to figure out where that is, where's the closest x-axis, and what's its angle measure. If it's bigger than 360, then it's going to be a bigger number. If it's less than 0, then it's going to be negative. Okay, so if we're looking here at this picture number 7, we have our angle already graphed for us. This gets us to negative 500, so we see we're in the negatives. So again, right, this starts 0, negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, right? And I could keep going, but I don't need to go any further because this is what we need right here. And so hopefully you can see where the reference angle is, but it's always between the terminal side and the closest x-axis. So again, I can't go over here because that's obtuse. This is the y-axis, so my alpha is here. All right. So when I think about negatives, it's the same thing I was saying before. Don't just use the negative as a direction, okay? So I'm just going to take this as positives. I also know the reference angle is positive here. So I'm just going to use the positive angle measures once you can set up the quadrantals in the direction. So my alpha here is just going to be the difference between, this is negative 500 and this is negative 540. And so basically I'm just going to take the positives, 540 minus 500, my alpha measure is 40. Okay. Yeah, that's all I wanted to say. All right, same thing over here, except we're given the angle measure. It's not graph for us, so we're just going to have to set up the graph. So 490 is positive, 0, right? I know this is more than 360, so I can already go around to 360, plus another 90 is 450, 540. All right, well, 490 is in between there, so I can kind of stop. So I know already that 490 is going to be something like this. It's positive, so I went up. All right, now my alpha is in between the terminal side and the closest x-axis. Well, I didn't mean to make these both the same, but that's all right. All right, so this is 490. And so now I do 540 minus 490. Get 50 degrees. So here my reference angle is 50. All right, this could keep going around, right? You just have to keep adding on 360s or keep subtracting off 360s. Okay. All right, I'm on for office hours. This one's due by Sunday. You guys can do it. I'm proud of you, and I'm out. Schulte, simplified. Maybe that'll be my tagline.